Hello, friends. Welcome back to our second part of chapter 3, where we will learn about a special type of collection, which is list. So, as explained earlier, whenever we say collection, it is, in a way to collect similar kind of objects. You can also collect dissimilar objects, but generally, you should collect similar kind of objects in a collection. Okay. So, so basically, a collection can be of many types. So in this course, we will learn about list, then we will learn about sets, then we will learn about maps, and we will learn about queues. So now what is special about lists? List is a ordered collection. Ordered word is very important. Basically means we collect the similar type of objects in an order. So what is this order? This is the order in which elements are inserted. So the insertion order is preserved in this special type of collection. So in this course, we will learn about two different types of lists. We will learn about array list and we will learn about linked list. There are other types of lists as well. There are vectors. There are other many types of list available, but for the scope of this course, we'll learn about two basic and elementary type of list, which is array list and linked list. Okay. So speaking of array list, it is index based. So you can access, what do you mean by index based list? You can access any element in the list using the index of that list. So 0, 1, 2, index always starts from 0. Starting from the 0 position, 1, 2, 3, 4, you can access any element in the list using its index. And because you can access any element using its index, it is very fast for random access. Basically, and it is resizable. It doesn't have a fixed size. So you can continue to add any number of elements in the list. So let's try to visualize it. You create my list is equal to new array list. What will happen in the memory is it will initialize an empty array like this 0, 1, 2, 3 up to a fixed length. It will initialize an array. So a list will array, but you don't need to go into the implementations how it is built. You just need to focus on that it is resizable. You can add as many elements as you want. So suppose you add a character here, then you add b, you continue to add, and on character n, it has reached the end of this list. Okay, and as soon as you add your next character, you add m, then you try to add. What it will do is it will resize the internal array, accommodate additional elements, and as soon as you continue to add elements, it will continue to resize the internal array, so you will be able to add as many elements as you want. Okay. And now suppose you want to access the element at position 1, so you know that b is living at 1 position. So in one CPU cycle operation you can access it. Suppose you want to suppose you want to access the element at position 14. In one CPU cycle you can go to the directly to the position 14, and you will come to know that the value there is. So this is why it is very fast for random access. Okay. And it is an index based list. It has every element is associated with an index. Now the disadvantage is, suppose in between n and m you want to introduce a new string. You want to introduce, you say, alpha. Now which means that all the characters m, o, p, whatever are here, they will have to shift one character ahead. So this will have to this position to make this position empty, so that your new element can go inside this position. So because of this, adding and removing from middle very flow in an array list. Okay, you need to remember this point about the array list. Now let's talk about linked list. So linked list is created using nodes. Okay, so every node has two of properties. One is the value. The second part contains a pointer to the next. So it points to the next node. It again has value, and the back part, the tail part, again points to the next block. This way, a linked list is created. In every case, the right part has a pointer to the next element. Because of this, it has been given the name linked list, because every node is linked to the next node. So now in array list, if you wanted to um, um, get the value which is living at index 14, you could directly go to the index 14 and fetch that value. But in case of array list, you cannot go to index 14. You have to go one by one. You have to go from next 1, then 2, then 3, then 4, then 5, then 6. You have to move 14 steps to reach the 14th index. You cannot go directly because there is no index here, like in array list, there used to be 0, 1, 2, 3. Here, no index is maintained. There is no index maintenance here. Here you have to crawl 1, 2, 3, 4. You have to count and go to the 14th index, and then you will reach there and you will know, okay, this is my 14th element that I need to read. Okay. So it is a non-index based data structure, and because of this, random access very, if you want to randomly access any element, that is very cool. You have to crawl node by node, and go and search for your element. That is the only possibility there in linked list. But there is one advantage as well. If you want to add the element at the end of the list, you just need to create a new node. And it will point to the next element. Again, you want to add one more element, just create a new node, and it will point to your next element. This way, whereas what will happen in case of array list, suppose originally the list was only till here. The inbuilt array was here, and you wanted to add a new element at this position. So it will have to create a new array and attach it at the back of this original array. So, this is a time taking process. The list has to increase its size so that you can add one more element. So adding an element at the end is not as fast in array list, but it is quite fast in linked list because it simply needs to create a node and attach it at the end. Random access is very slow, but adding and removing and vary, and not just the end. If you want to remove the first element of the list, what do you need to do? You just simply need to break this pointer. Then this will become an orphan, and it will be eventually removed from the list, and this will become your first element of your list. Okay. In this case, if you wanted to remove this element A, what needs to be done? If you want to remove this element A, everything B should shift to A position, C to shift. So every node will have to shift one index ahead. So lot of shifting is involved. So adding and removing at the end is very slow in an array list. Here you just need to break this connection, and this will become your first index. This will become an orphan. No one will come to know about it. It will get lost. Okay. So that is why adding and removing at the end is very fast in a linked list, but random access is very slow because we don't have an index in a linked list. Now let's see these two. Now we will create these two data structures in code and see. You can see in this array list example, you can ignore this part right now, which is generics, and we'll cover it later. You see at line number 8 here, we have created an array list. What we have written, list array list is equal to new array list. If you click on this class by holding control on Mac or command or control on Windows and command on Mac, you can go to the class as well. This is the array list class here. If you click here, you will go to the Java library, and here you can see this is the array list class. Okay. It has descriptions for different methods available as well. The class name is ArrayList. and you can see it implements the list interface. Ignore this part, which is generics. We will cover in the last part of this course. So it is a implements the list interface. It implements some other interfaces as well. You can ignore them as of now. Right now, you need to focus on implementing the list interface. So we have created an object of array list here. You can write array list as well. This is polymorphism. You can write array list is equal to new array list as well. But we try to generalize our code. So we refer it with its parent interface. So that is why we have referred list array list equal to new array list. Okay. So now I'm adding some elements into this. So I'm not giving it that place this value at the 0 index. I'm not telling it place this value at the first index, place this value at the second index. The order in which you insert the values, in those absolutely in the same order these value get inserted in the list as well. So automatically Java will be saved at the 0 index, Python will be saved at the first index, and JavaScript will be saved at the second index. Okay. Now if you want to access element at 0 position, you can say get 0. If you want to access element at 1 position, you can say get 1. If you want to access the value at 2 second position, you can give get 2. If you do get 3, it will give you an exception, because at third index there is no element. You have not even added element at third index. Why are you trying to access it? That is why it will give you an exception. Then we can write a for loop. This is a modern for loop. Earlier what we used to do, we used to write it like this. We used to say for int I is equal to 0, I is less than ArrayList.size plus plus. And then we can do the same thing here. What we're doing, we can print ArrayList. So this is the old way of writing the for loop. This is the new way of writing the for loop. You can simply give a collection at the end and then access each of these values one by one. Okay, so let's try to debug this program. So when we debug this program, you see now array list, we can see its size is 0 right now. Okay, the object has been created, but its size is 0. Now as soon as we execute line number 10, you can see its size is already updated to 1. And if you hover over this array list, you can see at 0th position it has Java. Now if I execute line number 11, we can see its size has already updated 2. And if you hover over this position, you can see both those Java elements present. And similarly, if you execute the next line and again hover, you can see all the 3 added in the list, and you can see its size as well. So if you do get 2, you see it has printed JavaScript, which was the element at second position. Now we are trying to iterate over the list. First time it is printing the first element. Second time the iteration will run, it will print the second element. Third time the iteration will run and it will print the third element. So this way, you can access the elements in the list. This for loop is written again. So, it will do one more round of this printing. And if you now what you are doing is, if you want to update an element at a particular position, so if you hover over this array list, you can see at 0 position we have Java, at 1 position we have Python, and at 2 position we have JavaScript. But now I am calling this add method, and I'm giving it an index as well. Here we were not giving an index. Whenever you don't give an index, it will add it at the end of the list. But now I am specifying that add this element at this first index. Now we can see that at first index already an element is present, which is Python. But if we execute this line, what will happen? Now if we hover over the list, what it has done is, it has done a shifting. At first position it has added C++, and it has shifted Python to the second position and shifted JavaScript to the next position, which is the fourth position. Now the size is also increased to C, but it has done a shifting internally as well. So that is why, adding and removing elements in the middle is time taking in an array list, because it has to do shifting. So if you print the complete array list, which we are doing at line number 27, it has printed the complete array list which contains 4 values: Java, C++, Python, and JavaScript. So this was the array list example. Let's try to see the linked list example as well. So this is the linked list example. You can ignore this generic block. So basically, if I try to explain you, it defines that it is a collection of this particular type. So because you have defined it string, you can only add string here. Okay. And if you remove this, then you can add anything here. For example, it was earlier string, and if I try to add an integer here, it will give me a compilation error. It is fixing the type of elements that can be added in the list. This is what this generic block does. But if I remove this block, you see this compilation error goes. Now I can add any object in this list. So to specify or to enforce adding of similar type of elements in a collection, it can be array list, it can be linked list, in any collection, we use this generic block. We will talk about this in a more detail as well. But for as of now, you can simply remember that it is used to define the type of objects that can be added in that collection. It doesn't add any object. It just defines the type. So let's remove this. Let's run this code as well. So at line number 7, it will create a new linked list. If you hover, right now the size of the list is 0 and it has created the linked list object. It is empty. As soon as you do an add, size has become 1. If you hover over the linked list again, you can see that first element has been added. Now there is another method available in linked list, which is add first. If we'll do this, let's see what does it do at line number 9. Instead of add, I'm calling add first. Now if I hover over this list, it has added Java at the first position and it has shifted C++ one step back. Now we did this in ArrayList as well. But there this operation is slow because it has to do the shifting of the remaining elements. But here in linked list, this operation will be fast. You will not come to know the difference in a small list, but when it contains thousands and thousands of elements, then you will see the performance impact. But you need to remember why it is fast here, because it doesn't have to do any shifting. It has just to add a pointer, create a node, and point the first node with this node, and this node will become the first node then. Similarly, is add last element method as well. It just needs to create a node and point the last element to this node, and this new node will become the last element of that array list. Okay. So if we do add last at line number 10, and again we hover over the list, we can see now the list contains 3 elements. Java is at the front, C++ is at the middle, and Python is at. And this get 0, get 1, get 2 operation you can do here also. But here this operation will be slow because it will not have any index to go directly. It will go from first, then to second, then to third, then to fourth. It will do a crawling and it will go. So you can call get 0. If I try to show you by evaluate expression, anything you want to evaluate, you can highlight it and right click and do this evaluate expression. So evaluate, it was showing Java. You can do get 1, then it will show C++, and if you do get 2, it will show Python. If you get 3, it will give you an exception as well, because there is nothing there. So it is trying to get an element. Now you can remove an element as well. You can tell that remove the element which is at index 6. Again, it will do the crawling. In ArrayList, it will directly jump to that element, but here it will do the crawling. So you are removing an element at index 1. If you execute this and again check the list, now it contains only 2 elements, Java and Python, because C++ has been removed. So you can print the list as well. Now it contains only 2 elements. Okay. And you can iterate over the list as well. Here also we are iterating over the list and we are printing the element. Now the for loop knows that this list contains string. If you remove this generic block, then for loop doesn't know that you contain string or what do you contain. So you will have to write object here. Unless otherwise you'll get a compilation error. But because in the generic block, you had specified that it contains a string. So the for loop knows that this contains a string. So you can iterate over the list, and one by one you can print all the elements that you want. So again, it has printed Java and Python one by one. So hope with this you are clear about the list section of the collection or the list interface in the collection. We have studied two types of list, ArrayList and LinkedList. These are the two important lists. If you understand this, you will understand rest of the list as well. Okay? Because all these are extension of these kind of lists. Vector we have not covered because it is not generally used nowadays. So it is kind of a redundant thing. So all the best and continue watching.